Hi, I'm Ashay. I'm an engineer by training and a storyteller by passion. I made this podcast to talk about data science, but no math, no equations, just intuitions behind data science. The episodes are not in any particular order, and you can just tune into any episode and listen to something related to data science. Let's get started. So, I know this game that kids play called Guess Who, which has many similarities to decision trees and entropy. And in this episode, I'm going to talk about that game and then how that relates to training decision trees in machine learning and the concept of entropy and information gain. So this game, Guess Who, has a it's a two-player game. It has a deck of cards, and on each card there is a character. And by character, what I mean is it has a face and it has a name. Now, both players choose a card, one card each from that deck, and then each player is also given a set of, let's say, 20 characters, and the card that every player has chosen belongs to one of the characters in that set that every player has. Now, the idea of the game is you have to guess the character of your opponent in as few questions as possible. So, what you do is you keep asking questions based on the features of that character. So, every character has a feature. Some characters have blue eyes, some characters are wearing some accessories, some characters have black hair. So, you ask questions to your opponent that result in a yes or no answer, and then same way opponent also asks you questions. You take turns, and then the whole idea is you need to reach the character of your opponent in as few questions as possible. That means you need to ask questions that will give you the maximum information about the character that your opponent has, right? The most ideal scenario is, let's say if there are 20 characters in front of you, and if you ask a question, again hypothetically, does your character have blue eyes, and the opponent says yes, and in the 20 characters only one character has blue eyes, so you can basically remove all 19 characters that don't have blue eyes, and obviously the remaining character is the character of the opponent. So this is the most ideal scenario because it gave you the most information about the opponent's character. This is exactly how uh, decision trees work and decision trees are trained. So you have data. Every data point has some feature associated with it, and you have a dependent variable which is the result of the independent variables in the data, and or a dependent feature that is result of some independent features of the data. And the whole idea is you um ask data a question based on certain features, and whichever gets you to your intended result or intended dependent feature quickest is the feature that you should use in the earliest step of your decision tree. um, and the information that you get by asking that question whether the data should be split on that feature, that information gain is something that can be calculated. And entropy is basically the opposite of information gain. So entropy basically means that the level of uncertainty you have in reaching the intended outcome, the level of uncertainty in the decision that you're taking based on a particular feature, that will um, prevent you in reaching the outcome as fast as possible. That's what entropy is. So again, in our guess who game example, if you ask a question that Does the character have black hair? And then um, if your if out of 20 characters that you have in front of you, if half of them have black hair and half of them don't have black hair, then you can only remove, if based on the answer of that question, you can only remove half of your set. But if the character has blue eyes, and if 19 of them don't have blue eyes and only one of the characters has blue eyes, that means you can remove 19 of them and you can reach the conclusion or intended decision much faster. And that's why that question, or eye color of the eyes, that the feature of that data has the most information about the intended outcome, has the least entropy and most information gain. Thanks for tuning in. I made this podcast to talk about intuitions behind data science, and we'll talk about some other idea in the next episode. There will be no math, no equations, just intuitions behind data science. See you soon.